Hey guys, hope you guys are having a great week so far. What I wanted to do was take this opportunity to finish up the problems that we did in class. So we already did one through five, or excuse me, 1 through 4, but we didn't do five, right? And five is Air Spares. It is a wholesaler that stocks engine components and test equipment for the commercial aircraft industry. New customers placed an order for 8 high bypass turbine engines, which increases fuel economy. The variable cost is 3.3 million per unit, and the credit price is 3.605 million each. Credit is extended for one period, and based on historical experience, payments for about one out of every 250 such orders is never collected. The required return is 3.9% per period. The customer will not buy if credit is not extended. So what we have to do in this problem first is figure out what's the net present value per engine purchased on credit. We need to figure out what is the break-even profitability of default in part A, and then in C, we actually have two parts to part C. We need to we are supposed to suppose that customers who don't default become repeat customers and place the same order every period forever. Further, assume that repeat customers never default. What's the NPV per engine purchased on credit? So what we're going to do here is we're just going to start with part A. Okay, so we're just going to start with part A. In part A, once the NPV per engine on credit. And if I remember correctly, I thought we covered something similar to this in class. I might be mistaken. So what we need to do is we need to figure out the cash outlay for the credit decision. And in order to do that, we need to recognize that, hey, that cash outlay for this decision is the variable cost of the engine, right? And if you remember, the variable cost of the engine was 3.3 million. Now, this is a one-time order, right? So the cash inflow is the present value of the sales price of the engine times 1 minus the default probability. So in order for us to figure out the NPV per unit, what we're going to do is we're going to take the net present value equals our negative cash outlay, right? It's a one-time order, so we need to add to this 1 minus 0.004. Okay, this 1 minus 0.004, that's the default probability, right? They said 1 out of every 250 customers we don't collect on, right, when we do this kind of arrangement. So we need to get that, or we need to include that, and we also need to factor in the money that we're going to be receiving, right, which they said it was 3.605 million. divided by 1.039. Okay, and the 1.039, that is the return that we need. Okay, so if we go ahead and run the numbers, we can see that the net present value equals $155,803.66, and that's per engine. So in that case, we should go ahead and fill the order. Why? Well, because our net present value is positive. So we should definitely fill this order. Okay. Now, B wants us to find the break-even probability of default. Okay. So we need to use the NPV equation that we used in part A, which is right here, and we need to set it to 0, and we need to solve for our pi, right? So for part B, what we need to do then is say NPV equals 0 equals, and then we add in our negative 3.3 million, which is our outlay, plus 1 minus pi, times our cash inflow, which is 3.605 million, divided by 1.039. And we go ahead and run the numbers. We see that pi ends up equaling 0.0489, or 4.89%. Okay? Now we need to figure out C, right? C says, hey, if we make this first sale and we offer this customer credit, they're going to end up becoming a repeat customer, right? So when we have a repeat customer, we need to recognize that the cash inflow actually changes. Okay, the cash inflow is now 1 minus the default probability times the sell price minus the variable cost. So what we need to do is to use the sales price minus the variable cost, since we have to build another engine for the customer in one period. Now, this cash inflow now becomes a perpetuity, right? Because they said they're going to keep on ordering forever. So the net present value needs to be calculated as, and bear with me, I'm just going to erase a little bit. So now we're going to move on to C, and we're going to use this new equation that we have, or I shouldn't say new, the different equation that we have for whenever we have a repeat customer and we're issuing them credit. Okay. All right. So for this is going to be actually C1. We need to use that that repeat customer equation, if you will, that shows that those cash flow or those cash inflows have changed. So we're going to start with NPV, net present value, equals our outflow, which is 3.3 million, plus 1 minus the default rate, which is 0.004, times, now we're going to use, remember in class we mentioned we're going to use our CM, which is our sales, 3.605 million minus 3.3 million divided by 1.039, which is our return that we require. Okay, so we now can see that the net present value here in this case is going to equal $489,230.77. And again, that's going to be per unit or per engine. And in this case, we should fill the order. And again, why are we? What are we basing that on? Well, we're basing the decision to fill or not fill an order based on net present value. And as long as our net present value is positive, we're going to fill the order. Okay. Now we have to figure out what the break-even default probability is under these new assumptions. Okay. So we're going to use the same same equation that we use for part B, but we're going to factor in the fact that this is a repeat customer, and when the cash flows change from a repeat customer or for a repeat customer, we have to use that contribution margin. So we're going to set it equal to NPV equals 0 equals negative 3.3 million. That's our variable cost, plus 1 minus pi times our 3.605 million minus 3.3 million divided by 1.039. And when we run the numbers and solve for pi, we see that we're looking at 0.5780, or we're looking at 57.80%. So in this case, we really don't want to accept the order, right? Why? Or let me rephrase that. We would not accept the order if the default probability was higher than our 57.8%. Now this default probability is much higher than the default probability that we calculated in part B, right? Why? Well, because the customer may become a repeat customer. Okay, so that's why the default probability differed there. So the next one that we have to work on here is 6, number 6. Okay, and number 6 deals with Sanchez Incorporated. They're considering a change in its cash-only sales policy. The new terms of the sale would be net 1 month. The required return is 88%, or I'm sorry, the required rate of return is 0.88%, and again that's per month. Okay, and in the problem they give us some numbers, right? They show us the price per unit under the current policy versus the new policy. They show us the cost per unit new policy, or current policy and the new policy, and they show us the unit sales per month. So if you notice, and if you remember from class, we talked about why would someone, or why would a business offer credit, a credit sales policy? Well, we said it's to increase sales, right? So we have the unit sales per month. The current sales are 1,080. However, under the new policy, they anticipate that the sales level is going to jump. It's going to jump by 100 units. Okay? So what we need to do is calculate the NPV of the decision to switch. So we're working on, should we switch or should we not? So how do we do that? Well, in order to do that, we need to first figure out what is the total revenue for the current policy, and then to that we have to add the increase in cost. Okay, so very simple to do. So what we want to do then is figure out the cost of switching, which is, first, what's our revenue? Well, if we take 1,020, that's our current policy price per unit, times how many units are we selling? Well, we're selling 1,080. To that, we add the costs that we're incurring to switching. So what costs are we incurred to switch? Well, think about it. The variable cost is going to be $830. Okay. Basically, what that means is, for each unit we produce, it costs us $830. Okay. If we produce one unit, our variable cost is $830. If we produce another unit, if we produce 2 units, it's going to our variable cost, or our cost per unit rather, is going to increase by the same amount. So it's going to be what, 1660, right? So we need to show that increased cost. How we do that's very simple. We just take the difference in the units, right? 1180 minus 1080 is 100 units. So our total cost of switching is going to be 1,184,600. Okay. Now we need to determine, okay, well, what's the benefit of switching to this new policy? And in order for us to do that, what we need to do sorry, is we need to take the new sales price minus the variable cost per unit times those incremental units that are sold. Okay, so that's easy. So the benefit is going to be our new sales price. Well, incidentally, the sales price didn't change, so we're still going to use 1,020, and we're going to subtract out our variable cost of 830, and then we're going to multiply that by the incremental increase in our units, which is 1180 minus 1080, and we end up with $19,000. Okay, and basically what we did here is we took our contribution margin, right, which we remember, and if you remember from class, we said the contribution margin is sales minus our variable cost. That's our CM, our contribution margin. So we're multiplying our contribution margin by the increase units, which is 100 units, times increase in units, which is 100. So basically we're going to have an increase to our bottom line, or our net income, of $19,000. Okay, so now what we need to do is we need to figure out what is our NPV. And that's very simple, right? Well, we have an increased cost of 1,000,000. Need to make that a negative because it's an outflow. 1,184,600, and I need to add my increase, or my benefit, which is the increase in the income. By the way, it's a plus sign. 19,000 divided by my required return, which they tell us it's 0.0088, right? Or 0.88% per month, which is what we had up there. Take it out 2 decimal places. That's why we have the 0.0088. So our NPV of switching is 974,490.91. Okay, so what happens now? Well, the firm is going to have to bear the cost of sales for 1 month before they receive any revenue from credit sales, right? Because it's all a timing issue, and we said that, hey, the new sales terms are going to be net 1 month. So from that point, or under those circumstances, we're going to have to wait 1 month before we receive any revenue from those credit sales. Okay, now this is why the initial cost is just for 1 month. Receivables will grow over the 1 month credit period, and then they should hopefully remain stable with payments and new sales offsetting one another. Okay, and again, that's in perfect world. All right, so let's look at 7. Number 7 deals with Provenza Manufacturing. So Provenza Manufacturing uses 2,100 switch assemblies per week, and then reorders another 2,100. The relevant carrying cost per switch assembly is $8, and the fixed cost is $1,050. So what we need to do is figure out in part A, what are the carrying costs? And that's pretty easy for us to do, right? So to figure out the carrying costs, we take our 2,100, which we order, which we use per week, and then reorder another one. Okay, so our calculation of carrying costs is going to be 2,100. We're going to divide that by 2, and then we're going to multiply that by our cost of $8. So we can see here that our carrying cost equal $8,400. Okay, now the order costs are the number of orders times the cost of an order. Okay, so the order cost is the number of orders times the order cost. Okay, so they tell us that we basically use 2100 switches every week and then reorder. Well, there's 52 weeks in a year, so I'm going to take 52 and I'm going to multiply it by the fixed order cost. And the problem tells us that the fixed order cost is 1,050. So we see then that our order cost is equal to $54,600. So then we have the economic order quantity, okay, or that's the EOQ, and just running with the formula that was in the book, we're going to take 2 times T times F divided by CC raised to the 1/2 power. Okay, so let's just fill in these numbers here, right? So T stands for the number of times we order. So we're going to have 2 times 52 plus F, which F is going to be our fixed costs. I'm sorry. Why did I say plus? That's a times. My bad. Times our fixed cost, which is $1,050. And we're going to divide by our cost, or our assembly cost, or our carrying cost of $8. Okay, actually bear with me here, I missed one element, I apologize. 2, the T is going to be the 52, the number of times we order, times our F, which our F is going to be our fixed carrying costs, which is the 1050, and then we need to also multiply the 2100, okay, because those are the number of units or assembly switches that we use. Okay, we're going to divide that by $8, which is our carrying costs, and then we're going to raise all this to the 1/2 power, and we end up with an EOQ equal to 5353.97. Okay, so what we can say here is that the firm's policy is not optimal. Why? Well, it's because the carrying costs and the order costs, they're not equal. So the company should increase the order size and actually decrease the number of orders. Okay, that was 7. So let's do 8. And number 8 deals with Tectonics store. And they tell us in the problem that the store begins each week with 560 phasers in stock. So we have 560 phasers in stock. The stock is depleted each week and reordered. The carrying cost per phaser is $51. So the carrying cost is $51. Okay. The fixed order cost is $99. Okay, so this is an identical problem to what we had before, right? The first thing we need to do, obviously, is figure out what are the carrying costs, right? And that's pretty easy for us to do. We know we have 560, right? That's what we start with for the units, and then we reorder these, okay? So we're going to take our inventory, 560 divided by 2, times our carrying costs of $51. We end up with $14,280. So that's your answer for part A. What is the carrying costs? $14,280. Part B, or item B, wants us to figure out what are the order costs. Well, that's easy. We can do that. The order costs deal with restocking, right? So we take the number of times we order, which is 52 weeks, times our fixed order cost of $99. We end up with a restocking cost or reordering cost of $5,148. Now, we need to use the economic order quantity. So the EOQ, okay? So we take 2T times F divided by our carrying cost, all raised to the 1/2 power. So again, we're going to say 2 times 52 times 560 times $99 divided by $51, all taken to the 1/2 power. We end up with 336.24 units. So the firm's policy, again, it's not optimal. Why? Well, the carrying costs and the reorder costs, they're not equal. So the company should decrease the order size and they should increase the number of orders. Now, the number of orders per year will be total units sold per year divided by the EOQ. So the number of orders per year, and this is for actually part E. So we're going to take our 52 times 560 divided by our EOQ, which is 336.24. We end up with 86.61 orders per year. Okay, and let's see, the next one we have deals with Snedeker Corporation. They're considering a change, right? Right now they're cash only, but they're considering doing credit sales. It would be terms would be net 1 period, and the return, or the required return, is 1.5%. So this one's a little different in the sense that our price per unit actually changes. So what we have here is we have, let's see, our required return is 1.5, okay, percent per period. I'm going to put a C for current. I'm going to put an N for new. We have the price. The current policy is $59. The new policy is $61. The cost, I'm just going to say VC for variable cost, 33 under the current policy. New policy, same thing, $33. Okay, and the number of units actually changes. Under the current policy, we're selling 2450. Under the new policy, our units will increase to 2575. So what we need to do is calculate the NPV of the decision to change the credit policy. So what we need to do is figure out the cash flow from either policy. So to figure out the cash flow, we're going to take our price minus our variable cost and divide it by our quantity. Okay, so the cash flow for the old policy, we'll go with the old, is going to be 59 minus 33 divided by 2450. We end up with $63,700. That's our cash flow. Okay, and we do the cash flow for the new policy. So we have a change in price here. So the new price is going to be $61 minus the variable cost, which is 33. That has not changed. And we're going to divide by our new quantity, which is 2575, and that ends up equaling 72,100. So now what we need to do is figure out what is the incremental cash flow, right? Now we need to recognize that this incremental cash flow is going to be a perpetuity, right? So the cost of initiating the new cost policy is as follows. We take PQ plus the variable costs minus the change in the quantity, Q prime minus Q. Okay, so that's pretty easy for us to do, right? So the NPV is going to be the 59 times 2450 plus 33 times that change in quantity and then we're going to need to add to that 8,400 over 0.015. The 0.015, that is our required return, and the $8,400 is, I believe that's a change in the policy. So the NPV equals $411,325. Okay. So that was number 9. Number 10, don't worry about number 10. Um, we did not cover that in class, so really don't even worry about that. So those are the answers to the last, well, four really, um, in-class problems that we have. Okay, so good luck with that. Read or give it a try as you're watching the videos. Give the homework a try. Not homework. Give the in-class assignments a try. And if you have any questions, please feel free and reach out to me. Just shoot me a text, and we'll be good to go. All right. Have a great weekend, and we'll see you on Monday.